Hi, this is PJ Piper. I'm the CEO of UV Technologies. I have with me Dr. Nels Olson and Jamie Childress, both from Boeing, and we're going to talk about current applications of 222 nanometer far UV in transportation and buildings. Quick background on far UV Technologies. We are a global leader in 222 nanometers since 2016. Yep, that's right. We didn't start with the pandemic. We've been doing this for a little over 4 years. We started focusing on foodborne illness under a NASA SBIR grant, and then proceeded to work into hospital-acquired infections, MRSA, C. diff, et cetera. And more recently, we're under contract with the Air Force, focusing on SARS-CoV-2 products and remediation. We are the only far UV end product that is currently made in the United States. We work with most of the commercial and academic partners that have gone before us in the IUVA conference schedule. We work with both suppliers, USHO and Eden Park. We work with Columbia University Medical Center, so the three speakers for the far UVC basics we work closely with, as well as a variety of other partners. More recently, within the past month or so, we entered into a strategic licensing agreement with Boeing to develop high-powered far UVC wands for disinfection of transportation applications. We are a member of IUVA as well as the American Society for Photobiology. And Jamie, if you'd like to introduce yourself and Boeing in this 222 space.
So yes, this is Jamie Childress, and so Boeing's been working on 222 nanometer technology for actually starting in more like about 2015, but it didn't become public until 2016 when we revealed that we were working on a far UV lavatory. And so that lavatory actually flew in 2019 on a 777 aircraft, which was then demonstrated at air shows all around the world. As you can see in the bottom slide there, we've been working more recently on the technology that we licensed to far UV, which is a high-powered 222 nanometer wand. And as PJ mentions, I mean, this is a very high-powered device capable of disinfecting against the SARS-CoV-2 virus in a small fraction of a second. So it's much more powerful than most of the 222 or any of the other UV systems that are out there. And we started these efforts looking at all of the available UV technologies. So we didn't start this because we were in the 222 business. We started this because we wanted to have high power and very rapid disinfection on aircraft. And so, you know, we looked at lots of different technologies and selected 222 for really three primary reasons. One is the human safety part that you've heard about from various other people in this briefing activity. And then the other one, the second one, is the ability to have very high power, much higher power than, let's say, you can get from LEDs or even from mercury lamps. And then the last one is that mercury itself is a banned substance on aircraft in flight. So you actually could not take, without an FAA waiver, a mercury lamp onto an aircraft in flight. And we do constantly reevaluate the UV disinfection technology, again, constantly second guessing ourselves and looking to see whether LEDs or something else is actually a superior technology. And in each case, even very recent reevaluation, 222 has won that trade study every time. So there you go.
So we're going to transition a little bit into some of the applications that we're actually commercializing and selling into the market, and where some of it is. I know that's the topic, the session topic. But first and foremost, what's the problem statement? And I would say it's clear that SARS-CoV-2 at this point is not under control. And so even with the best disinfection practices that we have today, social distancing, wearing face masks, good hand hygiene, the reality is there are significant challenges in creating a safe environment when you have to rely on human practices to implement those solutions. There's always the ability for people not to stand far enough apart, for the face mask to be worn wrong or not enforced. And of course, most people don't wash their hands long enough, probably never have. So a lot of the advantage for, and we're going to talk about two different versions of the use of far UV. And so the first one is largely what far UV Technologies has been focusing on, which are sealing applications for occupied settings. And then we're going to talk a little bit about the newer technology that we're working with on the Boeing side, on the WAN side, which is much faster, higher power, and requires PPE at this point. So the nice part about a sealing lamp that operates under the TLVs for safety is it is completely independent of human error. It's a set it and forget it solution. You put it on a ceiling, and we can actually achieve as many as 30 one-log reductions throughout the course of a day at standing head height. And so that's a pretty big deal because it's shown that SARS-CoV-2 is often transmitted in airborne kind of environments. But the other nice thing is it's actually in the room. So unlike a ductwork UVC system, which cannot treat surfaces, we also treat the surfaces. Some more recently peer-reviewed studies have even indicated that using far UV in a space is equivalent to even having an extra N95 mask on for all of the occupants in the room. So as an added layer of safety, we don't deem that it's good enough to just use a far UV light. We recommend people still use their best practices of social distancing, face masks, and hand hygiene, but to also then now add this as a fourth pillar of safety. Where are we installed? Well, because we got a lot of our initial funding and research and development through government contracts. Not surprisingly, we're quite involved with the Department of Defense, particularly the Air Force. And so not surprisingly, our product looks a lot like a smoke detector. An oversized smoke detector. It doesn't emit visible light. It's 222 nanometer light, which is not visible to people, so it doesn't change your environment to a purple hue or anything like that. But it will be treating all of the surfaces and the air between this light and whatever surface that lights can hit. So there could be shadowing, but for the most part, in a respiratory disease, when somebody breathes, talks, coughs, sneezes, or sings, it comes out in the air and it will eventually find its way by gravity to the surface beneath it. And the nice part about this, of course, the biggest deal about this is it can be used in occupied spaces, and 100% of the contamination events are caused by unoccupied setting. Somebody has to be there to actually breathe out that virus. But of course, we're not limited to defense applications. If you travel through Atlanta Airport right now, you can see our far UV lights in action, protecting people there. If you're traveling by bus, there are several lines right now that have done that, converted their lines to having far UVC protection in them. There are a whole host of dentists and medical clinics and hospitals that have been adopting far UV. So don't be surprised the next time you look up at your dentist, if you see this funny looking smoke detector-like device. Feel extra comfort in the fact that the aerosolized environment that you're in, that the previous person was in, is likely disinfected from the addition of that light. There are so many applications, it's almost hard to go through them all. Think anywhere where there's a confined space, typically indoors, maybe not good ventilation, and it's really it's hard not to think of a good application for this. Many people don't realize that, I think a lot of people thought far UV just came out of the woodwork this year. And so I think part of our message is that, Boeing has been in this for over 5 years. Far UV technology has been in it for over 4 years. and we've been hard at work. We have done all our own microbiological studies on several pathogens, E. coli, B. cereus, mold, and the like, largely under the NASA contracts. So we've done our own plating, we've done PCR, we've done a variety of those. And we have a very extensive lab facilities for every known NIST calibrated 222 meter that we know of, full spectroradiometers, so we can see the full spectrum of these things. And of course, a full 3D printing lab, filter development. And more recently, we've started getting much more involved in computational fluid dynamics to understand how we think about average disinfection in air, which is much more multivariable and complicated than surface disinfection, which is a more straightforward calculation. But we are far from the only ones doing this. Half of these papers were actually written by IUVA members, whether it's Boeing, FAR UV, or USHIO, or Carl Linden. Columbia University Medical Center has a lot, and there's a variety of other ones in Europe and Asia that have been publishing almost like crazy over the last 6, 9, 12 months, but even well before then. Why is 222 nanometer intrinsically safe? I'm not going to spend a lot of time on this. You've heard probably a lot of it before from Dr. Brenner earlier. At the end of the day, the 222 simply can't penetrate human and animal tissue. And that's a physics-based thing. So it can penetrate the bacteria and viruses that are airborne or right on the surface, but fortunately it doesn't get through the dead skin layer that we have, and it has been proven. One of the things that's often said sometimes in the presentations is this is a really promising technology. And actually, we don't like the word promising, or our customers don't, because they make it seem like, oh, it's not ready, it's next year. And I think what people are talking about promising is they've shown now that it almost doesn't matter how much 222 nanometer light, if you can have that pure wavelength or some narrow region there filtered, and we'll talk about that next. But you can actually, they've proven up to 500 millijoules or more that there's virtually no impact, whether it's in animal studies, in vivo, in vitro, and even on human studies. So it is safe. And then the next question we always get is it effective? And Jamie, since you're an expert on this particular topic, maybe you could spend a couple minutes talking about the difference between 222 and 254.
So as you can see in this this slide on the left-hand side, probably and this has been discussed in previous briefings, but the bottom line really boils down to that 254 has relatively little protein interaction. So as you can see in this again this picture on the left, the interaction at 222 with protein is roughly 20 times as great as it is for 254, and that has a giant impact, in its ability to penetrate skin and other materials. So not simply skin, but actually pretty much any polymer is effectively only gets a surface penetration, so which also improves the fact that it does not harm structurally any materials, at least that we've been able to determine. So those things are all good. And then a second good thing is that 222, because it does interact with protein, that protein interaction can also have a beneficial effect on the actual pathogen inactivation mechanism. So 222 both interacts with DNA as well as protein, whereas in the case of 254, or that entire spectrum from say 254 to 280, is primarily interacting with DNA with very little interaction with protein.
And one of the things that's interesting about that is SARS-CoV-2 happens to be a protein enveloped virus. So it actually, I think we're seeing that the 222 is actually more effective against this type of virus. And I think some of the previous papers by Dr. Linden and others show that it can be often an order of magnitude better than 254 against things like adenoviruses and other challenging ones like that. In general, I think we often see that it kind of balances out, and some things it's better than, some things it's a little worse than, but it's fairly comparable, I think, to 254 in inactivation of a lot of things. One thing to note for the academic community is if you are measuring inactivation, when you use PCR, because we're not hitting the DNA as much, the DNA won't be destroyed, but the infectivity of this pathogen or the virus will be taken away. So it's no longer infective, but the RNA will still be there. So you can get false positives just using a PCR test. So one of the things we did want to point out is that Hiroshima and MRI Global and some of the others that we've worked with have just used TCID 50 tests to be able to show what the actual reduction is. Another thing that's not as well known is that we are actually our ceiling lamps, which you can actually see above me on the ceiling here, that I've been sitting under for 7 months, and the one at home for a couple of years, are in compliance with the standards that have been set for decades. So this is not a Wild West type thing for everyone. There are some enforcement things that I know have been talked about earlier, but there actually are very well-known standards that people can operate under. And then it's a function of understanding what wavelengths a particular excimer lamp can emit. And I know that was talked about on an earlier session, so I won't get too much into that, but that kind of brings into on an unfiltered basis with this kind of curve, you can actually have some lamps at lower power still be fairly effective at this. And then potentially when these threshold limits start to incorporate some of the latest data and findings, the stuff that I talked to as promising earlier, and these limits may be raised, then you're going to see an increased importance in things like filters to make sure that as those go up, you don't have the corresponding, little humps of the less desirable wavelengths go up. And I might ask Nels if he could comment a little bit on where he sees the threshold limit values and maybe where your opinion based on the data suggests they may go.
Sure. Well, the original threshold limit values were set using data from various different sources, and they stood for a long time unchanged based on those original data sets. And the difficulty with those data sets is that they just about had to be polluted with those other wavelengths. So that's why we're really interested in seeing where the regulatory agencies and their advisors at ACGIH and ICNIRP are going to go with the threshold limit values now that those threshold limit values have been challenged by multiple different teams, right? And the challenge is in the data. It's not that we're asking for something unusual here. Every agency has a way of challenging their threshold limit values. ACGIH and ICNIRP are no exception to that. And we've presented the paper that you showed earlier in the many papers that have been presented to on these subjects to ACGIH to indicate that a new consideration of the threshold limit values be made now using the data that we cite in that paper and the calculations that we made, basically just doing a curve fit to the current data to show that, the threshold limit values probably should go up. And it's for very simple reasons. Early studies didn't have access to the kinds of filters that we have, and today, because they couldn't make them, and they didn't have access to the light sources we have today. So when they tried to generate the wavelengths that they needed, they had to do it with extraordinary circumstances, like the use of monochrometers. And monochrometers are great for doing science experiments on absorbance and those kinds of things. But the only way to get a pure wavelength out of a monochrometer is to then couple it with a blocking filter so that you don't get wavelengths that are up higher than, let's say, 230 nanometers or so. And that simply wasn't done in the old experiments that were done really long time ago, many decades ago. Yeah. So we're really hoping to see that the new data is considered by the regulatory agencies and their TLV setting teams, and can't wait to see what happens there.
Great. Couple other quick things. We often get asked as a product manufacturer, hey, do you have are you registered with the FDA? And the answer is actually very clear. We are not a medical device. We do not cure COVID from people. All we do is we treat a virus that might come out of a person in their environment. So either the air or the surfaces. And in discussions with the FDA, they said, well, then you're more like a Clorox wipe, and therefore you would be regulated by the Environmental Protection Agency. So I think they walked through some of these aspects earlier about the EPA, and we have our establishment number and comply with all the fee for the labeling requirements. We do produce out of an ISO 9001 manufacturing facility, and interestingly enough, they mentioned a lot of the UL challenges earlier. We're a 12 volt device. We actually don't have a light source, and so we don't require UL approval to be used. And but we did go ahead and we got our CE certification because we have a few marine clients in Europe that to get their marine certification, we needed to get CE first. So we are, perhaps unnecessarily, but we are the only FAR UV CE certified device in the world as well at this point. So the products are actually very simple. You know, again, it's much like so again, this is our occupied Krypton 11 or Krypton 36s, which are different heights used, but it comes in a box. You take it out of the box, and if you have a drop ceiling, you use this clip, you attach it, you run the line to a voltage drop from 100 to 277 volts down to your 12 volt DC, and you're done. One of the really nice things about FAR UV is, unlike a disinfection like deionization or UVC that works in the ductwork, you can actually measure at any square inch of your facility how much disinfection you would expect in that. And it's completely independent of the environmental impacts of airflow, temperature, or humidity. So you can use a NIST calibrated equipment, and you can go out, you can say at this height, you will end up with a certain amount of milliwatts right here. And knowing what the pathogen is and the amount of time that that is on, you can determine your millijoules and exactly how many 1 or 3 log reductions you might expect in that spot, in that place, whether it's standing head height, sitting height, the floor, or wherever else you might want to measure. So it's a little bit unique, and that's nice. We are certifying all of our installations, and we think that this concept of certification with NIST calibrated devices could be a really nice standard setting option for compliance or whatever as the industry continues to evolve, and we're happy to share activities there. SARS-CoV-2 efficacy, I think that was talked about earlier, but I think the other great thing about FAR UV in an occupied setting is that you're not just treating SARS-CoV-2, you're treating any of the other unfortunate viruses or bacteria that happen to be in that airspace or surfaces. And so that includes the most common hospital-acquired infections like MRSA or C. diff, the foodborne illness, E. coli, salmonella, or even, you know, your average cold and flu. All of these in bold have already been proven, either by us or others in the space. And all of these not in bold are low-hanging fruit. And what we like to envision is coming out of this pandemic with a renewed understanding and appreciation of the value of disinfection technologies. We envision a world where a lot of hopefully disease can be mitigated or eradicated. Everything that, from things you'd get in school to things you get in hospitals and the places you'd go to eat. Again, SARS-CoV-2, I think it was mentioned earlier, Hiroshima University has already proven that specifically. And again, TCID 50 assays are required to appropriately measure this with far UV devices. We already talked about the competitive advantages. Most commonly, our competition are either UVC in ductwork or deionization systems. And the primary challenge with those is airflows. It's all dependent on the airflow and whether that air gets even through the ventilation system and or whether those particles are unstable enough to actually reach the pathogens that they're trying to treat. These are some examples of our products. They're on our webpage. And in addition to our sealing products, our newest line of products are wands for disinfection, particularly in transportation. So the Krypton M, which stands for mobile, is this one, which can be used in a variety of different applications. It's not as powerful as what we're going to call our Krypton Plus or Krypton Max, which is kind of shown here. And this is modeled after the Boeing version. But it's kind of cool because a lot of people, when they see our sealing lights, they're like, wow, is this like Star Trek, everything's gone? And the answer is no. It takes several minutes under the current TLVs, 16 to 30 minutes at head level to even get 1 log reduction. But if those TLVs are increased, the big deal is it just means faster disinfection. And we already know, as Jamie mentioned earlier, that the power capabilities in krypton chloride wands are already at the point where we can achieve 3 log reductions or more within seconds. And we're doing it today in cockpits of airplanes. And so it's a very exciting future. We're excited to be a part of it. I don't know, that's really all I had. Jamie or Nels, I don't know if you have any parting comments?
I guess my only parting comment is that I think that I think there's sort of a sense that this is not just something, this desire for increased disinfection is not something that's going to go away when, the pandemic sort of winds down as people get vaccinated. That, as with any war fighting activity, I mean, the bottom line is when you come into a new war, you always fight with the weapons that you had developed in advance. It's the fabled "come as you are" war, right? So and in this case, our war is with a virus, this particular virus, but the next war will be with some other virus. And because at the start of any war, you fight that war in a come as you are way. I think people have sort of woken up to the fact that viruses really are a war, and the economic cost to not dealing with them in advance is grave. So I think that this basic trend is not going to disappear when this particular pandemic is taken care of.
Couldn't agree more. Really important that we're proactive here and that we realize that through the course of history, since the time of Christ, the pandemic and epidemic threat to the human race has gotten closer and closer and closer together until today. And we're asymptotic on about 3 years apart, and for the distances between in years, epidemics that could become pandemics. You'll remember that SARS and MERS have both happened in the last decade or two. They just keep getting closer together. And we need to have better tools, and this is an important tool in that fight.
Great. Well, thank you very much. We really appreciate your time.